Now we're going to continue looking at slow changing dimension techniques, but this time using a couple of commands that Microsoft has included in SQL Server. One is the intersect command and the other is the accept. We'll see how these can be used in ETL processing. So we are going to start with a couple of tables. Let me go ahead and reset the demo again. This stored procedure I've made here will reset the demo every time I call it. It'll make it a little bit easier to work with. So what it does is it just drops the customers table and the temp customers table, if they exist, and recreates them and adds a couple of rows of data. It's very, very simple. Now when I execute this, it gets everything all set up. Okay, with that in place, let's compare the differences between the tables. Now, we can, as a human, just compare the differences. To force SQL Server to do that, we can tell it to look in the customers table and identify what is in this result that does not show up in this result. The columns have to match. The names don't have to match. The data types have to be compatible. And of course, you'd normally want to pull it from different tables. When I run this, it'll show me what is unique from the first that's not in the first that's not in the second. Now, Microsoft has another one called Intersect. Come on. This does the opposite. What it does is it shows what the two tables have in common. So right now there are no rows in common, and that makes perfect sense because these two rows are in the customers table only. Now we can use this in combination with something called a CTE. This is the CTE called Change Customers. A CTE is a common table expression. And the way it's written is you put the with command up here at the top, then you make up a name of some type. I call it changed customers. Then after the as keyword, you put code that you want to run. And what happens is that when this code runs, it will give you a table of values. That table of values will be stored in memory. It's restored as a just temporarily as the code runs, then it disappears. It's a pseudo table. Now, when that code is running, you can reference that pseudo table in your code. In this case, I'm just looking for a list of customer IDs, a list of customer IDs that appear in the customers table but not in dim customers. Using that, I know that I need to insert data into dim customers. And as such, I go through and insert any customer where the customer ID is found in the customers table but not found in my dim customers. So this is an example of how the accept is used. Now, if I run the check here, I can see, yes, it's been synchronized. Update is going to basically do the same thing. Reason for that is when I compare the differences, I can see that Robert Smith up here is different than Bob Smith, and R Smith is different than B Smith. Now what happens is I do the same comparison, and it compares all the columns. And if it finds that there is a difference, and in this case there are two columns that are different, it goes ahead and gives me that result. Knowing that, I can apply an update to any rows where the customer ID was found in that list. And I'll just do so by going through and saying, okay, change the customer name column and the email column based on these IDs. Now, this particular code is going to go through and make the changes for me pretty quickly. And I'll see that the update has occurred. And of course, delete will work the same way. I'll go ahead and delete the second row. We can see that it's gone from customers, but still exists in dim customers. The code now, though, has to be changed a little bit. For deletion to work, we need to look at the dim customers table and see what's in there that's not in customers. If something's been deleted from customers, this is what we use for the comparison. Once we find that there are rows that are in dim customers but not in customers, we delete those rows. Throughout the course, I've advocated using stored procedures for your ETL processing. The typical stored procedure would look like this, where I create a stored procedure by typing in create procedure and come up with some kind of name for the stored procedure. If we were using parameters, the parameters would go directly after that. And we should actually put a little prologue before we start actually put the programming code. In the prologue, you would have things like the developer's name, the description, when they made a change, what change they made, and who made the change. Other things can go in here like dates and various other fields that you want to track. Now after that, you put the as keyword and you put the body of the stored procedure. The body of the stored procedure starts with begin and ends with end. In between, we declare variables for, like in this case, the return code. Add validation logic if you need it. Create a begin and end try block and a begin and end catch block. The try block allows us to go ahead and try to process code, and if it fails, automatically jump down to the catch block where we can process error handling. My personal preference is to return a status of positive numbers, usually 100, 200, 300, and a status of negative numbers, negative 100, 200, 300. Positive when things go well, negative when things do not. Finally, I return the values of the return code. There are plenty of stored procedure tutorials and demos, but you'll also find on my YouTube site a number of videos talking about the creation of stored procedures for more detail. But let's go ahead and continue on. I'll show you an example of how we would create a stored procedure using the code that we just looked at. Let's start off with the insert part first. So I'm going to create a stored procedure called ETL insert dim customers. I'll record my name, identify what it's going to do. Next, I'll go ahead and declare my return code, add no validation logic, but between the begin try and the end try, I put the code that we saw earlier, with the return code status being set to 100 if it successfully processes. That's it. And so basically I took the template and used that. I'll do the same for the update. Same code as above. I just go through and create it. I put between the begin try and the end try the code that we saw previously. And the same for delete. You see, once you get the code up and working, putting it inside of a stored procedure is not very difficult. And again, it's recommended to be recommended as a best practice. Now what I'll do is I'll make another stored procedure. This will be my master stored procedure. This master stored procedure will be called ETL dim customers, and it will call the other stored procedures. It'll perform the insert, the update, and the delete. Now, if I go ahead and call the master stored procedure, it will synchronize the tables. The reset demo just made it so that the tables are out of sync. There's data in customers, but not in dim customers. So if I execute that stored procedure, it'll synchronize it. Very, very simple. If I update and run the stored procedure again, synchronize. And of course, deletion is going to work the same. I can now schedule the stored procedure to run on a regular basis. The idea being that with the stored procedure code in place, I can set up automation. Oops, let me see here. Using SQL Array Agent. I'd go through and give it a name. I think a better name than that would be in order. And then in the steps, I would go through and set up a Transact SQL. Point to the correct database, and then put in my SQL code there. And finally, once I had that in place, I would go through and set up a schedule. And I could schedule it to run on a reoccurring basis. Once a day, once a week, once a month. Or if I set it to daily, I can go through and say every hour, or minutes or seconds. Very, very flexible. Now, I'd probably make a job for the database itself. And then the steps would be filling the different tables. At that point, I just go ahead and schedule it, and it will go through and fill all my tables automatically whenever the schedule comes up. So from that simple demonstration, you can see that those statements are pretty easy to use, and wrapping them into stored procedure is also very easy. It is perhaps not the most efficient way to do this. If we look at this code again, we see that each time the master store procedure fires, it has to run through the table 3 times. That is not ideal. Later on in another video, we'll look at Microsoft's merge command, which is much more efficient. Still, it's good to know how this is done. And we're going to look at a solution Microsoft provided in SSIS that does something similar. I'll see you in that video.